Here we have another quadratic. It's got an x squared and an x term, so I'm going to use this quadratic formula. The value for a is going to equal 1, b is going to be -8, and c is going to be equal to 6. Already once it's equal to 0, so I can just pull those values straight from the equation. I'd recommend you guys find b squared minus 4ac first. So in this situation, if you take -8 and multiply it by itself, you will get a positive 64. And then if I figure out -4 times a times c, I see I'm going to get a -24. Combining these two things together gives me a positive 40 to go underneath this part of the quadratic formula. For the rest of this stuff, of course, if b is -8, then the opposite of b is positive 8, plus or minus the square root of that number we just found, all divided by 2 times a, which again is just going to be 2. So 40, I've got this list in my head of 2 times 2, 3 times 3, 4 times 4, so on and so forth. The biggest one of these that goes into 40 will be 20 or less than 20. 16 does not go into 40, 9 doesn't go into 40, but 4 does, 10 times. So that's giving me 8 plus or minus the square root of the perfect square and whatever's left, all over 2. I'm going to go ahead and not worry about these numbers, but look at this grossness. Square root the part that I can. The square root of 4 is 2, root 10. And as a final step, I'll look at all these numbers on the outside of the radical. If they have a common factor, I'm going to divide it out. 8, 2, and 2 are all divisible by 2. If I divide 8 by 2, I get a 4. 2 divided by 2 is 1, so I don't need to write that. I can just have 1 root 10, so I can just put the root 10. And then there's no reason to put the 1 in the denominator either, because it's just going to end up, it's just not needed. So that'll be my final answer. Good luck.